Welcome to the Connect studio. My name's Janet Wood, and today I'm going to be talking to Michael Jesberger from TransnetBW. Michael, please join me on the stage.
Hi.
Nice to see you. Take a seat. Michael, we're seeing a lot of changes in the energy sector and in the power sector at the moment, and quite often the focus is on new generation sources, and particularly wind. But what does that mean for the network? How are you preparing for these kind of major changes?
Yeah, number one, it requires a good planning in advance. So we need to understand that our generation structure as well as the consumption structure in the future is going to change dramatically. Instead of having a lot of thermal and nuclear power plants distributed all over the country, we are now going to build a huge wind farm, let's say up north in Germany. And now we need to bring the energy down south. So this is something we need to plan, and then of course we need to rebuild the entire topology of our transmission grid. Therefore we are optimizing, we are reinforcing, but we also need new lines to cope with the future needs.
It's an ambitious rebuilding project. What's the progress with Südlink? I think that's one of the leading projects.
That's the biggest project of the energy transition in Germany. It's not only big in terms of length, it's a 750 kilometer long route from the northern part of Germany down south with 2 times 2 gigawatt. It's a new technology, at least for the German transmission system operator, since we are talking now about a huge DC link, so direct current compared to the alternating current we have so far in operation. And thirdly, it's also quite expensive. At the beginning we have planned to perform the Südlink as an overhead line 500 kV connection. Meanwhile, we are performing it with a cable, with a DC cable, 500 kV. So in total it sums up to a 10 billion euro project, which is to be commissioned in 28. And of course we have a lot of crossings from northern part of Germany down south, which is from the civil engineering also a challenge.
And is the project proceeding on schedule at the moment?
The project is on schedule in terms of engineering. We are delayed in terms of permissions. We are delayed in terms of acceptance in society. So the project team is now working since the first approval by the national regulator since 2012 on the permissions only. Of course we did engineering, we have also ordered our material which is under production, but we are lacking of permission and lacking of permits on the environmental side, on the routing side, so this is really a tough one.
Yes, and I think it's something that's perhaps underestimated in not just building generation, but in building the network that needs to connect it. How do you go about gaining acceptance from the people in the villages and the towns that you will be, where you'll need to install this new equipment?
Yeah. There's a lot of information necessary to not only to the politicians, to the authorities, also to society, and especially to the people which are living close to the routes. I have to admit that me as an engineer is never going to explain the people on a rational basis why it is necessary. So we have special communicators who have the right skills to discuss with the people, because at the end of the day it's an emotional issue. So it's not a rational one, it's an emotional. People have fear, they are thinking about electrical field, magnetic field, about the nature, about ecology, and therefore you need special skills and the engineer as such who argues with numbers is not the right one. Especially on the Südlink side, I think we have more than 1,000 events organized. We call them info markets. We have info centers along the route. We are very transparent in what we are doing. And we try to explain that there is no risk for human beings to have this line in operation later on. So a lot of money is invested to be transparent and for the communication.
Is it something where you would like to have more help from the companies that are building the new generation to say, this is what will be required to transmit the generation from our new projects?
Support is always welcome. For me, it's also an educational factor. On the one side, we want to stop the climate change, and we want to stop the melting of the poles. And this goes hand in hand with a lot of renewable generation resources we need today and in the future even more. And this big picture, I think everybody should have in its mind. Maybe it helps then to make it understandable why all these works and reinforcements and newly builds are necessary, because at the end of the day the wind is in the north, the sun is in the south, and the law of nature we cannot change. We can make use of it, out of it. And I hope that this is understood in society. Also, I can fully understand all these doubts and questions and a little bit of fear the people have.
And we've talked about the different characteristics that the generation has, but the grid has some different characteristics as well. When you withdraw fossil fuel plants and you start using renewables instead, and you need to bring on new types of equipment to help manage that, to keep the grid stable and to keep it operating. Would you talk a little bit about what you need to do to achieve that when we have a lot of renewables on the system?
Yeah. When you understand the law of nature and you want to make use out of PV, out of sun and wind, then of course you need completely different generation devices as we have operated in the past or even today. And with this change in generation, you also lose the characteristics of the old equipment. For example, reactive power compensation, all things around stability, grid stability, and we need to subsidize those technologies either with different technologies. So we are installing a lot of reactive power devices on a conventional basis, on a power electronics basis. We want to make use of the flexibilities we have in the converters, which are part of each and every PV plant or windmill. And of course there are new technologies which you cannot yet buy in the market, which we are developing together with the suppliers, such as a grid booster, who helps us to increase the utilization rate of the existing overhead lines in a way that we use this storage device for grid stability reasons. And that's, for an engineer, of course, it's a nice new technology.
Yes.
But at the end of the day, we need this type of devices and assets to cope with the challenges of the future. And the challenge of the future is we run the grid according the meteorology forecast and not necessarily on the availability of coal and oil.
So it will help manage the grid more efficiently and use the renewables that we have in a more effective way, and keep the grid within the limits of frequency and voltage that you have to work to. And we see a lot of new renewables coming on now, and there's a lot of enthusiasm for connecting more. But in some areas, the grid is not fully able to take on new renewables, and we often hear frustration from renewables companies that they'd like to connect and like to be able to start exporting, and they can't. How can you manage that congestion on the grid that exists? And I guess maybe there's short-term and long-term solutions to that.
Congestions in the grid we see on the distribution grid as well as on the transmission grid. In the past, there were no congestions in the grid because the grid was designed according to the generation structure we have had. Now, the congestions we have are a result of the delayed grid optimization, reinforcement, and grid expansion. And the planning says that we have in the future almost congestion-free grid. Almost. What we do so far until we have, and here the root cause is also the missing permits, is that we are redispatching, so we are buying a lot of expensive generation capacity here in the southern part of Germany and from our southern neighbors. And as we do so, we need to shut down the renewables in the north to keep the system stable. And this is something which is, of course, ecological not ideal, to say that a little bit more diplomatic, and it costs a lot of money. So we need to speed up with the permits, then we can build, and then we should have a congestion-free grid. What else do? We make use of load shifting elements until that time, so we are installing phase shifting transformers, series compensation devices, also new technologies we haven't had in the German grid so far, but they are necessary to reduce the size of congestions as we have them today. Third topic is are more or less trading mechanisms which are making us a little bit the life complicated. This is the 70% minimum remaining accessible margin we need to provide on the NTC, and so not all trading mechanisms we receive from Europe are helping us in reducing congestions.
Are you able to use customers to use more or less in response to your needs?
On the balancing side, yes. So if we could make use on the consumption side, on the load side, then this would help us to reduce congestions as well. We therefore have developed out of TransnetBW an app which is called Strom gedacht. So we are giving indication to the consumers that we have congestions on the next day and asking them to prepone or to postpone their consumption in terms of washing, for example, or other usages you can delay or prepone.
That sounds like something that you could use in the very short term, and that I think raises the question of the winter that we are just entering or we're already in.
Yeah.
It's going to be a difficult management challenge across Europe, I think. What kind of action can you take to help manage the situation over this coming winter?
I mean, we cannot influence the weather conditions, and we cannot influence the geopolitical decisions which are taken somewhere else. But what we did, all 4 transmission system operators, and I know from our electrical neighbors, they did the same. They have made in-depth analysis on various scenarios, what could happen, especially in January, February. This calculation we have called stress tests and performed in summer, early autumn this year, to get a good picture of what reaction span do we need to cope with the conditions once it's getting cold. The second one, we have purchased reserve power from our electrical neighbor, predominantly from Austria and from Switzerland, to keep the grid stable. Number 3, we are training a lot, so we are training also for the load shedding purpose. So we have made some black start exercises with a couple of other utilities in the southern part of Germany. We have installed communication paths to the authorities, to the government, and last but not least, we have introduced the app asking society, the people, to control a little bit better the consumption if possible. And there is a lot of more to say.
Great. Well, thank you very much. I'm sorry we don't have longer to discuss all of the measures you're taking, but that sounds very interesting, and the best of luck for this winter. Thank you.
Thank you very much.
Thank you very much, Michael and Jesberger. And you can catch all the interviews at enlit.world that we've carried out on the Connect stage. Thank you.